students, welcome to the math class. Students, in our previous class we have started with the topic continuity, and we have done the first topic of the continuity, that is continuity of a function at a point. Today we are going to discuss one example that is based on the modulus function, and we will check its continuity at the point. Then we will complete our next objective, that is continuity of a function on an interval. So let's start first with the example. Discuss the continuity of the function fx is equal to modulus function of x plus 1 plus modulus function of x plus 2 at x equal to minus 1 and x equal to minus 2. We have to check the continuity at 2 points, that is minus 1 and minus 2. Firstly, on the number line, when you plot these 2 points, so you can see that number line is divided into 3 parts. First type value is there when it is less than minus 2. Second type is when the value lies between minus 2 and minus 1. Thirdly, when the value is greater than minus 1. So, 3 type of intervals are there. We will check the value of this function in all the 3 intervals. Then we will check its continuity. Let's start with the very first value when x is less than minus 2. It means x can take any value which is less than minus 2. Let's take x is equal to minus 3. Now this is less than minus 2. Now check the value of the modulus function at this point. So firstly, when you put here, you will get minus 3 plus 1. So inner value is minus 2, which is negative. Similarly for the second, when you put the value, you will get minus 3 plus 2. So answer is minus 1. In both the cases, we are getting negative value. And according to the definition of the modulus function, it is having 2 values. First is minus x, second is plus x. Now minus x, it is there when value of x is less than 0. It means inner value when negative, it means it will have a negative sign. And secondly, when x is greater than equal to 0, then it will be positive. Now, on taking minus 3, both the inner values are negative. So, we can say that fx is equal to minus of x plus 1. Again here, minus sign. So, x plus 2. On simplifying it, we will get the first value of the function when x lies between minus infinity and minus 2. So it will be minus x minus 1. Here it is minus x minus 2. So finally on solving we will get minus 2x minus 3. Similarly, second case when x is greater than equal to minus 2 and less than minus 1. So here you can take any value that lies between minus 2 and minus 1. Take x is equal to minus 1.5. Now again start solving. You will check the sign of the value. In the first case, when you put here minus 1.5. So we get minus 1.5 plus 1. So answer is minus 0.5. So first value is negative and second minus 1.5 plus 2. So answer is 0.5. First is negative, second is positive. So here sign will be taken according to it. Fx is equal to minus of x plus 1 and plus x plus 2. On simplifying it, we will get the value of the function when x lies between minus 2 and minus 1, also for equal to sign. Now third case is there when x is greater than minus 1. So x is greater than minus 1. You can take any value, you can take 0, you can take 1. So when you put the value here, so you will get fx is equal to, when you take 0, so 0 plus 1, answer is 1, that is positive. 0 plus 2, so answer is 2, both are positive, so we will take the positive sign. So x plus 1 plus x plus 2. On simplifying it, we will get the value of the function. So these are all the calculations that I have shown you. You have to work according to it. Now I have written directly here. Okay, so on simplifying it, fx is equal to minus 2x minus 3 if x is less than minus 2. Second case, when you simplify the second part, here minus x and plus x will cancel out. So minus 1 plus 2, answer is 1 if x is greater than equal to minus 2 and less than minus 1. Third, it is equal to x plus x 2x plus 3 if x is greater than equal to minus 1. In this way, we will find the value of the function at different intervals. Now, we have to check the continuity at x is equal to minus 1. So, for continuity, we have to check the left hand value, right hand value and the value of the function at the given point. So, firstly, for x is equal to minus 1. Now, left hand limit, firstly, f of minus 1. Minus 1 means here value of x is equal to minus 1. So, here equal to sign is there. For x equal to minus 1, value of the function is 2x plus 3. So, here in place of x, we will put minus 1. So, 2 into minus 1 plus 3. So, answer is coming out to be 1. Now, left hand limit. Left hand limit means when x is approaching to minus 1 negative, value is less than minus 1 of fx. Now, look here. When x is less than minus 1, so value of the function is 1. So, this will give us the value of fx for left hand limit. And second part will give us the value of the function for right hand limit. So, here put the value of fx, it is 1. So, no x values are there. So, its answer is simply equal to 1. Now, come to the right hand limit. Right hand limit is equal to limit x approaches to minus 1 positive of fx. Now, in place of fx, put the value 2x plus 3. Now, as limit is minus 1 positive, so we will apply the h method. So, put x is equal to minus 1 plus h. As x approaches to minus 1, h will approach to 0. So, limit h approaches to 0, 2 into, in place of x, put the value minus 1 plus h plus 3. Now, when you applying the limit, so 2 into minus 1 plus 0 plus 3. On simplifying, we get minus 2 plus 3 is equal to 1. Now, left hand limit, right hand limit and value of the function at minus 1 all are equal. So, we can say that f is continuous at x equal to minus 1. In the same way, we will check the continuity at x equal to minus 2. Now, look here again. When it is x is equal to minus 2, for equal to we are having the same value, it is 1. and for x less than minus 2, it means for the left hand limit we will use the function minus 2x minus 3, and from here we will get the value for the right hand limit. So it is x greater than equal to minus 2, again its value will be 1. Now the same way we will discuss the continuity at x is equal to minus 2. Now continuity at x equal to minus 2. So f of minus 2 is equal to 1, because for x equal to minus 2, value of the function is 1. Now left hand limit. Limit x approaches to minus 2 negative fx. Now when value of x is less than minus 2 and value of the function is minus 2x minus 3. So here minus 2x minus 3. Applying h method, x is equal to minus 2 minus h. As x approaches to minus 2, h approaches to 0. So here we get limit h approaches to 0, minus 2 multiply with minus 2 minus h. In place of x, put the value minus 3. Now limit approaches to 0, we get minus 2 in bracket minus 2 minus 0 minus 3. So here 4 minus 3, so value is 1. Now right hand limit. Limit x approaches to minus 2 positive fx. Now value of x is greater than minus 2, answer is 1. So put here value 1. So finally answer is 1. Again left hand limit is equal to right hand limit equal to f of minus 2. So f is continuous at x equal to minus 2. In this way you can find the continuity of the modulus function at the given point. Now let's start with the next objective. In the previous section, we discussed the continuity of a function at a point. Now, next is we shall discuss the continuity of a function on an interval. Now, firstly, discuss the continuity of a function on an open interval. Now, open interval means endpoints are not included. We will consider the continuity of the function at any point that lies between the interval a and b. For example, we are having an interval 1 till 3. It is an open interval. It means endpoints are not included. If we take any point c in the interval 1 and 3, so at this point we will check the continuity. Here we will check the left continuity, right hand limit and the value of the function at this point, that is c. If all these values are equal, that is left hand limit, right hand limit and the value of the function at point c, then it is called continuous in the open interval. Now second case is here when it is a closed interval. In closed interval, endpoints are included. Say interval is 1, 3. Now here endpoints are also included. Firstly, we will check the continuity of a function at any point c that lies between 1 and 3. For at point c, we will check the left hand limit, right hand limit and value of the function at point c. Now, in the closed interval, as endpoints are included, so at 1 also we will check the right hand limit only, because this part is also included. And for 3, we will check the left hand limit. We will not check for right continuity. So in this way, we have to check the right hand limit at x equal to 1, left hand limit for x equal to 3 and left hand limit, right hand limit and value of the function at this point c. We will check f of 1 also and f of 3 also. If these two values are equal, f1 and right hand limit is equal and all these values are equal, only then we can say that function is continuous in the closed interval AB. Next is there continuity at everywhere. It means C belongs to the real line. Now a function f is said to be continuous everywhere if f is continuous at every point of the real line. C belongs to the real line. You can take any point. If the function is continuous everywhere on the real line, then it is continuous everywhere. Now let's discuss one example based on this topic. So discuss the continuity of the function f where fx is equal to 3 if x is greater than equal to 0, less than 1. It is equal to 4 if x is greater than equal to 1 and less than 3. Third, it is equal to 5 if x is greater than equal to 3 and less than 10. Now here you can see that so many points are there: 0, 1, 3 and 10. 0, 1, 3 and 10. It is greater than equal to 0. It means closed interval is here. It is starting with the closed interval. Last value is 10. It is less than. It means open interval is there. So here let's discuss how many times we will find the continuity at which point. So firstly, closed interval is there. It means here we will find the value of f of 0 and as it is right continuous, so we will check the right hand limit only. If both these values are equal, it means function is continuous at x equal to 0. Secondly, we will check the value for 0 till 1. Now for 0 till 1, we will take one point C which is belonging to this interval. Now for C, we will check left hand limit, right hand limit and value of FC. That is any point lies between 0 and 1. If all these are equal, then we can say that function is continuous in 0 till 1. Similarly, for the next, we will check for 1 till 3 and then 3 till 10. 3 till 10, we will check, take any point between 3 and 10. Then again check its continuity. We will not check the continuity at x equal to 10 because it is a open interval at 10. So it is a long question. Let's start with its first part. Firstly, write continuity at x equal to 0. You can see that at x equal to 0 only right continuity is possible. We will not check the left because interval is starting from 0. So here firstly f of 0, you can see that and x equal to 0, value of function is 3. So f of 0 is equal to 3. Next, right hand limit is equal to limit x approaches to 0 positive fx. So its value is fx3. So it is again 3. Both the values are equal. So it is right continuous at x equal to 0. As x equal to 0 is the left hand point, that's why we have not find the left hand limit. Okay. Now next is continuity at x equal to c where c is greater than 0 and less than 1. It means c lies in the interval 0 and 1. So we know that when xc is greater than 0, it means we will take the value x greater than 0. And second, c less than 1, it means x is less than 1. This is the left hand limit and this is the right hand limit. For both the limits we are having a same value, that is 3. So here FC at any point C lies between 0 till 1. You can say that only one function is there. So FC is equal to 3. Now for left hand limit x approaches to C negative of fx. For left hand limit we are having a value 3. So it is 3. So answer is 3. Similarly on the right hand limit, when x approaches to C positive, it means that is value is greater than C. So in this case also, that is again value is 3. So limit, right hand limit is equal to 3. Now left hand limit, right hand limit and value of the function at point C all are same. So we can say that f is continuous at x equal to C, where C is greater than 0 and less than 1. Now next point is we have to check the value equal to 1. So we will check the continuity at x equal to 1. So for x equal to 1, you can see that when x is equal to 1, value of the function is 4. So f1 is equal to 4. Now left hand limit, left means when value of x is less than 1. So for x equal to 1, it will give us the value for the left hand limit for x equal to 1. So here when x is less than 1, value of the function is 3. So it is equal to 3. On simplifying we get 3 only. And for right hand limit means when x is greater than 1. For x greater than 1, value of fx is 4. So put the value here. So we get 4. Now you can see that left hand limit is 3 and right hand limit is 4. As both these values are not equal, so we can say that f is not continuous at x equal to 1. Now next point is there, when x lies between 1 and 3, function is not continuous at 1. Next interval is 1, 3. So take any point in between them, that is point C. So continuity at x equal to C, where C lies between 1 and 3. Again, when the values lies between 1 and 3, you can see from the given function 1 and 3, answer is 4. So left hand limit is 4, right hand is also 4 and value of the function is also 4. So fx equal fc4, left hand limit, that is C negative, its value is 4, answer is 4. Again right hand limit, x approaches to C positive of fx, its value is 4, so again 4. All the values are equal, that is left hand limit, right hand limit and value of the function at point C, where C lies between 1 and 3. So we can say that f is continuous at x equal to C, where C is greater than 1 and less than 4. Next we will check the continuity at x is equal to 3. So for x equal to 3, value of the function. Now we will check the value of the function. When x is equal to 3, value of the function is 5. For less than 3, left hand limit, you can see that its value is 4. And for right hand limit at x equal to 3, its value is 5. So here f3 is equal to 5. Left hand limit is equal to 4, right hand limit is equal to 5. So here left hand limit and right hand limit are not equal. So we can say that f is not continuous at x equal to 3. Now last interval is left when value of x lies between 3 and 10. Again, take any point C. When value lies between 3 and 10, you can say that its value is coming out to be 5. So, again, for left hand limit, right hand limit, and value of the point lies between 3 and 10, value of the function is 5. So, here fc is equal to 5, left hand limit c negative fx, it is 5, right hand limit x approaches to c positive of fx is again 5. So here left hand limit, right hand limit, and value of the function at point c is equal. So we can say that f is continuous at x equal to c, where c is greater than 3 and less than 10. Now we have done 6 cases. And from all these 6 cases, we get f is continuous at all the points of its domain except for x is equal to 1 and x equal to 3. It means function is continuous at all the points but discontinuous at 1 and 3. In this way, we can check the continuity of a function on an interval. Students, I hope you got the topic now, how to find the continuity of a function on an interval. Before starting the work given in your SNAP homework, go through the links guided in the SNAP homework. It will help you to understand the topic. Next, we will continue in the next class. Thank you.